Everyone, and welcome. This is Professor Thayer with you, coming to you from the outdoor classroom at the Shapiro Writing Center here at Wesleyan University. And today we are going to talk to you about getting started with your Python. So let me go ahead and share my screen. You can follow along with your slides at home if you would like to do that. Those should be available on our course page, or you can watch the slides in the video. So this will be our first lecture series, and in this week we are going to take a look at the course overview. We'll also talk to you about getting started with Python. We'll show you how to work interactively versus working with the scripts. We'll also take a look at the computer hardware, formal and natural languages, levels of programming. We'll go from algorithms to programs, and finally we'll wrap up this week's discussion with the program execution. So let's go ahead and get started. So in this course, these are our objectives. We'll be learning to think like a computer scientist. We'll learn how to read, write, and reason about simple programs. So what we're going to be trying to do is learn how to do the things that computer scientists would be doing in the real world. That is not only just writing your own programs, but also how to read the programs that others have written, because oftentimes this is a task you're going to need to do. And also to reason about the programs, that is, think about how to put them together, think about organization, think about readability of the programs. All of these kinds of things will factor into becoming a great computer scientist. We'll also learn the mechanics of Python. Now, learning how to program doesn't necessarily mean learning Python specifically, but of course that is what we're going to be doing in this course. And part of that is learning about the syntax that's involved in writing the programs. That is, what are the commands that you need to use? How do I print something? How do I loop? How do I do these various things? So that syntax will be a major component of what we're going to cover in the course. And again, understanding programs that are written by others will also be something important, because that's a major way how we learn how to improve our computer skills, looking at the work of others and collaborating with others who may be on a project, because programmers really work independently. If you work at a computer program company, it's unlikely you are going to sit down from start to finish and write a complete program. You'll probably be interfacing with other programmers and or working on some code that has already been developed. Finally, we'll be using programming to solve interesting problems. At least I hope they're interesting to you. We will be challenging you to do a final project where you get to write your own program from start to finish yourself. So some of the things we'll need to be able to do in order to do this are to break the more complicated problems down into bite-sized pieces that you can solve with the tools that we are going to teach you how to work with in this course. We'll also then synthesize solutions by combining those smaller pieces together. And as we get into the functions, which is an upcoming topic, we will see how we can start to put the pieces together in order to make a larger program. So we'll be working with the Python programming language. I'd just like to mention that you can find this information at www.python.org. There is a wealth of information that you can use here, and I would highly encourage you to visit this website. So you can do a number of things here. This is where you can download and install the Python code, which we'll talk about momentarily. But there's also many other things that are available here. There's also documentation, there's PSFs, there's documents, there is a community that you can get involved with here. And so that may be something that you may want to get involved with. The author of Python is Guido van Rossum, who is depicted up here. Python is used in a variety of platforms. You may have heard of a Dropbox, and maybe have heard of a company called Google. And if you have ever used any of these, you have certainly encountered Python code. It's, of course, used in many, many other platforms as well. This is just a little cartoon that I put in here for you, a little Python humor. It says, so who is this Guido van Rossum? There's a Python that looks like he's actively digesting some yummy lunch. Hopefully that wasn't anybody too important, right? Getting started with Python. So You'll of course need to get Python to work on your computer. Now, some of you may be working with PCs or Macs, or you may be working with the Chromebook. And so the way that you're going to obtain Python for your computer system will be somewhat dependent on what kind of computer you're using and the actual setup at your particular school. So we will be working with the individual schools to work out how exactly we're going to make the solution for your situation. But in any case, just to give you an overview of the basic process of how you can get Python, it is freely available from that python.org webpage. And so maybe you have your own computers at home, or maybe you're working on a computer where somebody's already installed it for you. But in any case, this is what you can do. You can go to the python.org and you can go to downloads if you want to install it yourself. And then you need to select your operating system. Now, of course, if you're working on a Chromebook, Mac, or PC, it doesn't apply. You're going to have the Chromebook operating system. And so that's going to be a little bit more complicated in how you would actually install Python. What we will do is we will create a virtual machine on your computer. That is, we'll put another operating system. So you've heard of Macs and PCs. Well, there's another one called Linux. And so that operating system can be added onto your computer in addition to this one, and then we would be able to run the Python within that. So that is likely a situation you may find yourself in. Like I said, we'll be working with your schools individually to figure out what plan is going to be best for the situation and resources available for you. And we will be in touch with you about that. This just shows you how the Python can be downloaded. As you can see, you just click on the button and then you will get a Python package with a yellow and white parachute dropping outside your door. No, I'm just kidding. The package will arrive on your computer and then you would be installing that, or you may have some assistance in installing that. So you would basically, once you get it onto the computer, navigate to the downloads or wherever you saved it. Now this part will pretty much be the same from whenever you actually have the Python on your computer, regardless of how you got it there. You would navigate to your downloads or wherever you saved it, and then you would double click on the installation file. So it would look something like this. This is how it looks on my computer, and I have downloaded it. So you simply just double click on this, and then it will, you can check all of the standard features, and then you would be seeing the setup progress. As you can see, this is now installing the 64-bit version on Windows machine, which is what I was doing. And then at the end of this, you will just click through any of the prompts you may receive to install that, and then you should finally get this setup was successful window, and then you should be pretty much good to go once that has happened. So then what you're going to do is you're going to launch idle to run Python. So you would search for idle and not actually search for Python. Now, why is that? I will tell you in a minute. Idle is basically this part that's going to interface with Python for you. You can find this using your Mac Finder. On Windows, you could use that search bar, and on Chromebook, Ubuntu, or Linux, you would click on your terminal icon and then type idle and press return. So any of these different ways you could use in order to get your idle to launch. And when your idle launches, it will look something like this. Why are we using idle instead of Python? I thought we're learning how to program in Python. Professor Thayer, what's going on? Well, a Python program could be made in any text editor. You could, in fact, do this in Notepad or any kind of any other document, Office, Google Docs. You could write your Python program in any text editor. But let me ask you this: if you're going to write, an assignment for your English class, is that same editor going to help you in how to actually write your program? Will it indent things automatically? Will it color code it according to kinds of things it is, if it's a command or if it's keyword, if all these different things? And so we see that maybe there could be something that could be helpful for us that would be suited for doing something besides writing prose like poems and your reports for your other classes. And that's why we have something that will help you to write your code. And that is basically what an integrated development environment is about. It's a sort of a program that helps you to write the code. And so IDLE stands for Integrated Development and Learning Environment. And this is the one that comes standard with the Python package. It's an integrated development environment. It's a software application that helps programmers develop software code efficiently. It increases developer productivity by combining capabilities such as the software editing, building, testing, and packaging in the easy-to-use application. And we'll see how it will have some useful features for you. IDLE helps you program by color coding your work, showing errors, and allowing you to test and run your code. IDLE integrates the text writing, saving, debugging, and running with Python all in one place. IDLE is connecting your code being run with Python for you. It's basically just going from the actual Python then over into the execution of it. And so that is why we are launching IDLE and not Python directly. IDLE will be, in fact, using Python. And that is why we search for IDLE, and we're not, for example, trying to search for Python on our computers. So just a little tour of IDLE. This is some of the things you will see here. This is your version number. Just make sure that you're not using anything that starts with a 2 here. You really need to be in Python version 3 or your syntax will be substantially different. Ideally, you'd be in Python 3 point, and then this next number should be 5 or something above. This has been downloaded in July 2023, and this is version 11. So if you are downloading and installing close to the time, it's likely you will also be getting version 3.11 of some kind. The 4th, this is just a minor edit to the to the software. But the key thing is you want to see a 3 in this position. You want to see ideally 5 or a higher number in the second field, and then the last field is really not particularly important. These are your menu options. These are appearing across the top. It's also possible that your menu options may be appearing at the top of your screen. This is the typical style of the Macs, and you may find this in some of the Ubuntu's as well if you're running on the Chromebook. So just watch for where your windows are. They could be here, or like I said, at the top of your screen. And the other important thing, okay, is this right here. This is the prompt. This is your cursor is basically here, and when you start typing, this is where it will be. You should not be typing the arrows themselves. So when you're looking at some of our samples and so on, you may see in my screenshots that there are these 3 arrows or the chevrons or the greater than signs, however you want to look at that. You do not type those. That's actually the prompt where you should be typing. It's like little arrows pointing to you saying, type here. Okay, I also mentioned that you see there is this line here. This is an indentation line, and so your code will be appearing to the right of this. If you do happen to have a bit of an older version of Python, you may not actually have this line, and your prompt will be won't be in the margin. It will actually just appear directly under here. So it's the same thing, and you just again should not be typing the 3 arrows. You just type next to the 3 arrows. So let's talk about working interactively in the interpreter versus working with scripts. And when we say working in the interpreter, we mean the IDLE itself. And so Python can do quite a lot of things interactively, just like a 4-function calculator. You maybe have those things, or maybe you have one on your phone. You know, you want to know what's the answer to 2 + 2, and you would type 2 + 2 and press enter, and it will give you the answer 4. And so this is what we mean by interactive, that it tells you the answer right away, and Python will report that answer back to you. But of course, Python is much more than just a souped up pocket calculator. So let's just take a quick review of the arithmetic operators we'll talk about these more in the upcoming lectures, but of course Python can do many of the basic things that you're familiar with doing on your calculator, adding a plus b. So here I'm going to simply just define variables a and b to be 5 and 7. You're probably familiar with this sort of thing, variables from your algebra classes. And then we would want to know what's a plus b, so we simply substitute in those numbers. A is 5 and b is 7, and we would add them together to get 12, and Python can do this quite readily, which is a little bit more than your calculators can do, unless you have a more fancy scientific or a graphing calculator, but you may actually need to type in 5 plus 7. We can also do subtraction in a similar way, so we now can do b minus a, which would be 7 minus 5, which we get 2. Here we're going to do multiplication. Notice that the times symbol, you're probably accustomed to using the X or a cross symbol. Python will be using the star, and this can be found on the 8 key on your keyboard. And so here we multiply 7 times 5 to get 35. We can also do division. You may be familiar with this division symbol, and you probably also know about division also can be expressed as a fraction. They're actually equivalent. So a divided by b is the same thing as a over b written as a fraction. And so this would then come out to be the 0.714. And in Python, we're going to use the single slash. We'll also meet some other ways that you can do other styles of division in Python. Why use only one when you could also do others? So also there's the exponentiation, which I'll also just introduce you to. So 5 squared means 5 to the second power of 5 multiplied together 2 times. This would be 5 times 5 equals 25, which is the same as 5 squared. To calculate exponents in Python, you use the double star as the operator. You might be familiar with using the caret symbol for exponents from other programming languages or your calculator. But to do this in Python, you'll need to use the double star. So here I'm just illustrating 5 times 5 and then 5 to the second power, which is 25. 5 times 5 times 5 would be 5 to the third power, which is 125. And here we're showing 5 to the third power. So you can do any arbitrary power you wish using the double star indicator. Python can also execute commands interactively. So more than just doing 2 plus 2, you can also do commands. So here's an example of a print. This will be the first program you'll work on, the hello world. So here we're going to print hello world, and we see the Python responds by printing back the hello world to you. So that's working interactively. That seems pretty good. Why do we need to bother with learning how to use scripts, right? I mean, I could just work interactively, right? And in the sense, that's true, but there are a lot of advantages. Persistence is the first one that we will talk about. That is, you can save your work and open it up and continue to work on it later. If there weren't such thing as persistence and you closed your laptop or ran out of battery and you hadn't saved any files, how are you going to do your homework? You're going to have to start all over again. And so that's really not particularly a good situation. So we'd really like to be able to save files just like you're likely accustomed to doing in many of your other classes. You may also want to share your work with others. You might want to save and turn in your assignments. So if we didn't have files, then there would be no way to have homework and grade things. And also you might be involved in collaborative coding projects. So for example, maybe you want to share your code with someone else, or perhaps work with a library that someone else on the internet has made. And so by being able to save things into scripts, that enables that to be a possibility. It also allows you to develop complex code with many lines. And so there are ways that one can put multiple scripts together. And we will see a little bit of that in this course. But that's something that you would be working on as you become an increasingly expertise Python programmer. So then, how do we make a script? So you're going to do file, and then you'll go to the new file option, and it will make this window over here. So a couple of things to notice is that when we're working interactively, we recognize that it has this heading at the top, and this one lacks that heading. And also this one has those little arrows or chevrons here, whereas the script lacks that. And of course, when you press enter here, this one is going to respond, whereas this one is not going to do anything until you actually run your whole program. So this is how you can do a hello world. You'll actually be working on this. So here's what we're going to do. We're going to open our script, and then we're going to print the statement, print hello world into your program, right in the script. So you're going to print this. I will mention you also need to press the return after it so that your cursor actually goes over here. The screenshot doesn't capture the cursor, but just know that the cursor is gone over here. So the first thing is to type your program here. So there's your simple program. Then the next thing we're going to do is we're going to note what's going on in this bar up here. We see that it actually says untitled with these stars on it. So it's untitled because you haven't actually saved it as anything yet, and that's why it's called untitled, but soon that will change. And it also shows the stars anytime you have unsaved work. So since we have just been typing in here, there's unsaved work, so it will look like that. So then we're going to do run module. So we click on this run, and you'll have the option to pick run module, and it will ask you, would you like to save your work before you move on? And you need to say yes. And so you will be prompted to save your work, and you're going to click on OK. Now, problem students sometimes run into is that the standard location of where your files are going to be saved is some pretty archaic directory. And this is going to depend on your particular machine and its setup. And you may have a different one than your neighbor, even if you have the same computer. So this is some folder deep within my computer, and I'm never going to remember it. So if I save all my homework here and I need to go back and edit it later, or I need to study for the exam and open it up, I'm not going to be able to find it. So what you need to do is you need to be sure that you select a location on your computer where you can actually find your stuff. I would recommend that you save it wherever you typically are saving the work for your other classes. You can use the new folder to create a folder for specifically your Python course, which I do recommend. You might want to work in your My Documents. So here mine is called just Documents. Yours might be called My Documents. There's also the desktop option. Maybe you work on the cloud. That also could be an option. Use whatever folder, or the fancy word is directory, where you customarily do your coursework, and that should be a great choice of where to put it so that you can find it again later. So then once we have saved the file, then it will execute. So this is our script window where we had written it, and the output appears back over in the idle interactive interpreter window. So we see that we write over here and the output comes out over in a different window. So make sure you switch back and forth between your windows. And if this window is covering your other window, you need to make sure you move it out of the way so you can actually see it. And so we see that the output is going to display. You will get this restart every time you run a script because it's going to restart your shell, which means it's basically starting over and making all your variables fresh. And then the actual output, the output of printing literally hello world, is this hello world that appears over here. So it worked, and you should have the opportunity to work on that as well. When do you use scripts versus when do you work interactively? You should work interactively to get a quick math answer, to test out some syntax like the scratch paper, like maybe you're not sure, do I need single quotes, do I need double quotes, that kind of thing. Is this going to work? Maybe you have a new command that you're learning this day. You might want to quickly just check it out, and you can work interactively to do that. But generally we should be working in scripts. Most of the time you will working in the scripts, your homeworks, your worksheets, your projects, anything to turn in, you should really be moving over into working in the scripts. All right, well, that concludes our first segment of this week's lessons. I hope that this has been helpful, and we look forward to talking to you next